Hey guys, welcome to our first official lesson of Unit 4. So in Unit 4, what we're going to be looking at is we are going to be looking at solutions. So that stoichiometry concept is going to come back into play. But before we do that, we have to talk a little bit about solutions. And today we're going to talk about the concentration of solution. So concentration is a word that you've probably used before, and concentration just means kind of how strong something is, right? So if I say that this lemonade is very concentrated, it means that it's got a very strong lemonade taste. So we're going to take that concept and we're going to apply it to chemistry. So we're going to be using numbers to tell us how strong something is. So concentration, notice that here we have square brackets around C. That's actually a really great shortcut that we use in chemistry to represent concentration. So rather than having to write out the word concentration, if I put square brackets around something, it means it's concentration. So I actually use that almost daily in my grade 12 chemistry class. It's a great shortcut. So the actual definition, it's the ratio of quantity of solute in a solution. So essentially it's how much stuff quantity is dissolved in other stuff. So it's going to be a ratio. It's going to be a calculation that tells us how strong something is. Molar concentration, we call molar concentration molarity. So we are still using the concept of moles, and molar concentration is represented as this unit, moles per liter. So concentration in chemistry is always communicated in moles per liter. So we've actually got a really nice formula here that's always going to tell us the concentration. So concentration is represented by C. Well, if concentration is in moles per liter, then to calculate it, all you need to do is take the concentration N and divide it by the volume of something. So again, concentration is how much stuff, number of moles, you have dissolved into your solution, your volume. Notice here that number of moles is still measured in moles, but volume is in liters. That's where you get that mole per liter for your unit for concentration. That means that anytime we give you a volume, you're going to have to check to make sure that it's converted to liters. Think about a chemistry lab. I know we didn't get to do a lot of labs before we left, but think about in a chemistry lab or what you did in grade 9 or grade 10 chemistry. When you were measuring things, you were often measuring them in milliliters, right? 5 milliliters, 10 milliliters. There's very few times that we measure things in liters in a chemistry lab, because that's a big quantity, right? So oftentimes your unit for volume is going to be in milliliters, and you will have to convert to liters. So just keep that in mind. All right, we're going to get right into an example. We have our formula. So we're going to go through this example, and it's asking for the concentration of a saline solution, a salt solution. We're told that we have 3.5 grams of salts, sodium chloride, and we've dissolved that into 1.5 liters of water. So you're essentially making salt water in this case. So what we're going to start is we are going to write down with what we're given. So we were given a mass of sodium chloride, 3.5. We were given a volume of water, that's 1.5 liters. Remember, our formula is going to be concentration is the number of moles divided by the volume. So the good news is that we were given volume and we were actually given this in liters. The bad news is if you take a look here, the other value we were given isn't moles, but mass. So that's not ideal, but remember that we are actually able to calculate moles using mass. That's what we did last unit. So that's where we want to start, is we're going to calculate N. Once we have N, we can then find the concentration. So to calculate N is going to be mass divided by molar mass. We have the mass that was given to us in the question. We need to calculate the molar mass still. To calculate the molar mass of sodium chloride, we're going to take the mass of a sodium, we're going to take a mass of a chlorine, and we're going to add them together. So 22.99 plus 35.45. Remember, both of those units would be in grams per mole. So that's going to give me a molar mass of 58.44 grams per mole. So I now have mass. I now have molar mass. To find moles, I just need to go ahead and I need to divide them. So my formula is going to be number of moles equals mass divided by molar mass. I'm going to go ahead and plug in my mass. I'm going to go ahead and plug in my molar mass. And if I do this correctly, look at my grams is actually canceling out. By canceling out grams, I'm left with the unit of moles, which is what I'm looking for. So I now know that my number of moles is going to be 3.5 divided by 58.44. If I go ahead and I plug that into my calculator, I'm going to get this really nice long number here, and that's going to be in moles. Remember, the question was asking me for concentration. I've not discovered that yet. I've just discovered my number of moles. So now what I want to do is I want to go back and figure out concentration. Concentration is going to be number of moles, N, divided by volume, V. So I'm going to take my number of moles, that really nice long number from before. I'm going to divide it by my volume. Remember, concentration always has to be in moles per liter. So we need to check to make sure that volume is in liters, which it is. So I'm going to go ahead and divide by 1.5. If I go ahead and I plug that into my calculator, I get this really nice long number here. And check to make sure your unit is correct here. Your unit for molarity, molar concentration, is moles per liter. And that's what these units gave me. Let's consider significant digits. So we were given 2 decimals. So we want to go ahead and we want to round this to 2 decimals. Therefore, my concentration is going to be 0.04 moles per liter. Not too bad, right? So let's take a look at another example. In this example, this is asking how many moles of sugar. So it's giving us 2 different values. It's giving us a concentration. Now, be really careful here because I know what you're saying. You're saying that concentration is in moles per liter. This big capital M here, that's actually a shortcut for writing out moles per liter. So moles per liter is a great unit to use because it almost constantly reminds you of the formula that you're using. But rather than having to write out those 4 letters all the time, a big capital M is a shortcut. So when you see a big capital M, that just stands for moles per liter. So we were given our concentration, 0.5, and we were also given 250 mils, and it's asking for concentration. So let's start by writing down what we're given. We were given concentration, and we were given volume. The first thing that you should notice here is that your volume is actually in milliliters. This is typical, but again, we want to make sure that we're using liters because this unit here, let's make this smaller so you can read it easier. Remember, this unit here is in moles per liter. So since it's in moles per liter, that means that this here also has to be in liters. So our first step is going to be to go ahead and convert 250 mils to liters. To convert that to liters, all we have to do is divide by 1,000. So if you ever want to go from milliliters to liters, remember milli is 1,000. So divide that number by 1,000, and that's going to give you your number of liters. We now have our concentration. We now have our volume. Our last step is to figure out number of moles. Number of moles is going to be from that triangle we gave you equal to concentration times volume. So I want to take my concentration I was given. I want to take my volume that I was given that's been converted to liters, and I want to multiply them. So I'm going to take 0.5. I'm going to multiply them by 0.25. Now remember, I'm including units because I want to make sure that those units are going to cancel out. I can see that I have liters in the top. I can see that I have liters in the bottom. Oops. I can see I have liters in the top. I can see I have liters in the bottom. Those are going to cancel out, and that's going to leave me with the unit of mole. Leaving me with the unit of mole is the unit that I'm looking for, so that means that I've done my calculation correctly. If I go ahead and I plug that into my calculator, I'm going to find that I end up with 0.13 moles. I was given 2 decimals to start with, so I can go ahead and keep that number and say there's 0.13 moles needed to make 250 mils of 0.5 molar solution of sugar water. So those are the 2 types of questions that I could ask you using those formulas. Let's take a look at one more type of question, and that's going to be the molar concentration of ions. So we can use this to calculate the ratio of the concentration of a specific ion in solution. So to explain this, we're actually going to use an example. So let's look at this example. We are going to dissolve 0.212 moles of iron chloride into solution. It's going to make a 175 ml solution, and this is asking for the molar concentration of the molar concentration of the solutions and the concentration of the ions in solution. So the concentration of ions are going to be a little bit different. Let's start by going through and just writing down what we're given. So we're starting this question the exact same way we were starting our last question. We've recorded our number of moles, and we've recorded our volume. Again, volume always wants to be in liters. This volume is in milliliters. So in order to convert to liters, we're going to divide by 1,000, and we're going to have 0.175 liter. Now the question is asking us for the molar concentration, and it's also asking for the concentration of ions. I don't quite know how to do the concentration of ions, but let's go ahead and do the molar concentration. And our molar concentration is going to be exactly like we did in our first question, number of moles divided by our volume. So let's take our values that we know. Our values that we know are going to be 0.212 and volume 0.175. So we're going to take 0.212 and we're going to divide that by 0.175. And notice that by taking moles and dividing by liters, that's going to give me my unit of moles per liter, which is what I'm looking for. So I'm going to get this value here. Now my next step is I want to look at my molar ion concentration, so my concentration of my ions. In order to do this, I'm going to use the balanced chemical equation, and that's going to tell me how many ions I'm producing. So my balanced chemical equation is going to look like this. Iron 3 chloride is going to break down and it's going to form iron and it's going to form 3 chlorines. How did I know this? Well, if I take a look at iron, there's no number written after it, so we go ahead and we assume that's a 1. And if I take a look at chlorine, there's a 3 written after it. So that tells us that when this actually breaks down, we call that ionizes. When it splits into its different ions, it's going to form 3 chlorine ions. So we can now use this ratio, and we can use the concentration that we just calculate to figure out the concentration of iron ions and chlorine ions. Let's start by looking at the concentration of iron ions. So I know that my concentration of iron chloride is 1.2114. We just calculated that. So my concentration of iron chloride is 1.2114. In order to figure out my concentration of iron ions, I want to multiply it by that molar ratio. So my molar ratio, if I take a look in front of iron chloride, I have a 1. And if I take a look in front of iron, I also have a 1. So by doing this, by setting up my ratio this way, by having iron chloride in the bottom and by having iron in the top, what I've allowed myself to do is I've allowed myself to cancel out that iron chloride. By canceling out that iron chloride, it's going to leave me with the concentration of iron ions. Well, if I'm multiplying anything by 1, it's going to be the exact same number. So my concentration of iron ions is the exact same concentration of iron chloride. Not very exciting. But what we're going to look at now is the concentration of chlorine ions. So in order to figure out my concentration of chloride ions, I'm going to take my concentration of iron chloride and I'm going to multiply it by my molar ratio. I'm going to put iron chloride in the bottom. By putting iron chloride in the bottom, it allows me to cancel it out, and I'm going to put chlorine in the top. So I again have a 1 written in front of iron chloride because in my balanced chemical equation, it's a 1. But if I take a look for my chlorine, I'm putting a 3 in front of chlorine. Why am I putting a 3? Because every time that 1 iron chloride breaks down, 3 chlorines are going to be released. So you have 1 iron chloride is going to break down into 3 chlorines. This means that your concentration of chlorine ions is going to be 3 times that of iron chloride. So I'm going to take 1.2114, I'm going to multiply it by 3, and I'm going to end up with a total of 3.6342 moles per liter, which is my unit for concentration. I want to round that to 2 decimals, so I'm going to find that my concentration of chlorine is 3.63, whereas my concentration of iron would just be that 1.21. All right, so that's it. Those are the 3 types of questions that I could ask you. So here's some practice homework questions. Solutions are already posted. Good luck and join us for our next lesson when we keep talking about concentration. Bye, have a good day.